Greetings everyone and welcome to the second edition of this video on Strand 1.2. So today we are going to discuss on the topic of dimensional analysis. Chemistry is more than just laboratory work or theoretical aspect. It has to do with mathematical concepts as well. So in this particular topic we are going to learn how we are going to use those mathematical skills and solve some problems which will involve certain units. So we will learn how to derive units, and by solving this kind of problems we will also learn how we are going to use metric conversions to solve a particular question. Metric conversions play a very important role in solving certain mathematical equations. So you are expected to learn these metric conversions in terms of their exponential base units. And this is another thing that you need to memorize, which is called the conversion factor. You need to remember the conversion factor involving each of these variables. Okay, so for example, you should be able to convert centimeter into meter, moles into particles, atmosphere into millimeters of mercury, and so forth. So we will be using these conversion factors to solve a few equations and derive their relevant units. So now let's see how we are going to use dimensional analysis in deriving relevant units. The first and foremost thing to understand is this formula here. We can see the desired unit is what we want to obtain. Given unit is a variable that we are given. So we multiply the given unit by a fraction. Now this fraction is obtained from our conversion table. Okay, so now we have to think, why are we putting desired unit as a numerator and a given unit as a denominator? Why can't it be the other way around? So we are doing it like this so that the given unit on the numerator and the given unit as a denominator can cancel out, and we are left with a desired unit. Okay, so let's look at example number 1 and learn how this is used. So to convert 25 milliliters into liters, the first thing we do is to write down what is given. So we are given 25 milliliters. Now we are going to multiply it by a factor. So this is a factor that we are going to use. Okay, this factor is derived from the conversion table. So our conversion involves milliliters and liters. So now what is the conversion between a milliliter and a liter? It is 1 liter equivalent to 1000 milliliters. The next question we should ask ourselves is, where should the milliliter go? Should it be the numerator or should it be the denominator? Well, since we want to cancel the milliliter in the 25, we need to multiply by a fraction where the milliliter is the denominator. So we will put liter on top and milliliter at the bottom. By doing that, the milliliter sign can cancel out. And when we simplify this, this is what we get. And when we solve it, we get our liters as 0.025 liters. In the final exam, you're expected to write your answer in 2 decimal places unless otherwise stated. So you should also learn to follow the instructions that are given in the paper. Now let's look at example number 2. In example 2, we are converting a density of 3.26 grams per milliliter to its equivalent grams per liter. So try to underline or circle what is given to you already. We are given 3.26 grams per milliliter, so we write that information down. Now we need to multiply by a conversion factor. So we have to decide what do we want to cancel and what do we want to obtain. We want to get rid of the milliliter, and in place of that we need to put liters. So since the milliliter is the denominator here, we need to multiply by our conversion factor where the milliliter is the numerator. So once again, between milliliter and liter, the conversion is 1 liter to 1000 milliliters. So we are going to put the information like this now. We will put 1000 milliliter on top and 1 liter as a denominator. So we can cancel the milliliters. So again we expand this and this is what we get. So simplify this equation and we get 3260 grams per liter or 3260 grams per liter. As you can see how we can write the units, okay? So we can write the unit either in this format here, or we can just write it like this. So I hope you have understood the importance of using dimensional analysis now. Dimensional analysis actually helps us to derive a particular unit. So if you are given any complicated units and from there you have to derive to another unit, we have to make use of this concept. Now we're looking at the final example. Example 3. What is the mass in kilograms of a 1.5 liter liquid which has a density of 13.6 grams per milliliter? Now to solve this particular question, instead of using the density formula, which is density is equal to mass over volume, we need to simplify or solve this equation by using dimensional analysis. That means by cancelling out the units. So once again, let's write what is given to us. So this is our given unit, 13.6 grams per milliliter. Identify what we need to get rid of. We want to get rid of the milliliter so that we are left with the grams. And these grams will then be converted into kilograms. So to get rid of the milliliter, we need to multiply by a conversion factor involving milliliter. So the only conversion factor that we have learned that has a milliliter and liter is 1 liter equivalent to 1000 milliliters. Therefore, we will multiply by that conversion fraction. However, decide on what will be the numerator and what will be the denominator. Since we want to cancel off the milliliter, which is as a denominator in our given unit, we are going to multiply by a fraction where the 1000 milliliter will be the numerator. So this is how it will be written. Now the 1000 milliliter as a numerator and the 1 liter as a denominator. When this is written like this, then the milliliter can cancel out. Let's simplify this and we get our intermediate answer as 13,600 grams per liter. So this is how we write it as 13,600 grams per liter. Now again identify what we need to get rid of. So since we want to get the mass, which is in grams, we need to get rid of the liter. Go back to the question and see what is in the question that has already got the liter that can multiply to this to cancel the liter out. We have 1.5 liters here. Now, when we multiply 13,600 grams per liter by 1.5 liter, so this 1.5 liter will be our numerator. When we multiply that way, the liter can cancel out. So 13,600 grams multiplied by 1.5 and we get 20,400 grams. Now this 20,400 grams will now be converted into kilograms. So let's see. To convert that into kilograms, again we need to make use of dimensional analysis and the conversion factor. This time the conversion factor is going to be between grams and kilograms. So 1 kilogram is equivalent to 1000 grams. So again, what will be the numerator and what will be the denominator? Since we want to get rid of the grams and obtain kilograms, the grams is the numerator here. When we multiply, the fraction should have the 1000 grams as a denominator. So this is what we have. So now when we cancel the grams out, let's expand this. This is what we get. 20,400 times 1 kg divided by 1000. And we get our answer as 20.4 kilograms. So students, this is very easy. It's very interesting to use dimensional analysis in your questions, in your calculations to solve problems. And not only that, it makes a lot of calculation and problem solving easier. Okay, so I hope you have learned the concept behind dimensional analysis. And with that, I wish you all the best in your revision and tackling more problem solving questions. Take care. We will meet again in the next session. Bye.